Here we have question 2, and we can immediately see that we should start off by working with the left-hand side. So let's write that down. So here's what we're given. We've got two fractions added together. In the first fraction, we have 1 plus cos A over sine A plus sine A over 1 plus cos A. Now, seeing that we have two fractions added together with different denominators, we know that we need to get the denominators to be the same. So we can get this to be one fraction by applying the rule that we learned in the previous video. To get this to be one fraction, we need to have an LCD. So to get this new denominator, we are going to multiply both denominators together. Now, we can show them in brackets to show that they are being multiplied. So in one bracket, we have sine A, and in the other bracket, 1 plus cos A. Now to get the numerators, we are going to cross multiply. So we are going to take this 1 plus cos A, multiply it across with the 1 plus cos A. Notice how it is being multiplied by itself. So we can just write 1 plus cos A all squared. Then we've got a plus in between. We're going to cross multiply the other way. So we're going to take the sine A, multiply it across with sine A. Since the sine A here is being multiplied by itself, we can write that as sine squared A. In the next step, we can expand that bracket. So we've got a binomial squared. We know this is going to result in a trinomial. To get the first term, we square the first term. To get the middle term, we multiply both terms together and we times by 2. So this is going to give us positive 2 cos A. To get the third term, we are going to square that second term. So cos A times cos A is going to be cos squared A. Next to that, we've got plus sine squared A. And for now, let's actually keep the denominator as is. So most of the time what happens is you end up factorizing your numerator, and when you do so, something from the denominator cancels out. That's just the typical way that this goes. So for now, we keep the denominator as is, just in case that happens. If we need to multiply out the denominator, we can always do that later on. Now at the moment in the numerator, what we notice is that we have sine squared theta plus cos squared theta. Remember, that is our identity. Sine squared theta plus cos squared theta is equal to 1. Well, here we have it in terms of A, but that is the same thing. It's fine. What we can do is we can replace these two terms with 1. So here, in my numerator, I've replaced it with 1. Now we notice that we've got like terms at the top. We have 1 plus 1, which we can gather. We know that is going to be 2. So at the top, we've got 2 plus 2 cos A. Denominator will keep as is for now. Now, once you gather those like terms, something interesting you notice is that both your terms in the numerator contain 2. Since 2 is common in both these terms, let's pull it out as a common factor. So taking out 2 as a common factor, in your first term, you are left with 1. In the second term, you'll be left with positive cos A. I'm keeping the denominator as is, and this is exactly what I had mentioned to you. The typical way that these questions go, where we factorize the numerator and one of those factors ends up cancelling with something from the bottom. Notice how you've got 1 plus cos A in the numerator and 1 plus cos A in the denominator. They can cancel out with each other. Now what we're left with is just 2 in the numerator and sine A in the denominator. And if we go back to the question, that is actually what the right-hand side should equal to. So we can conclude and say that this is equal to the right-hand side. And we are done. Please remember to like, subscribe, and turn on your notifications for more content.